Most of you have enough time to work on this. We're finding the inverse, which is 2y to the fifth power plus 3, x minus 3 equal to 2y fifth, x minus 3 over 2 equal to y fifth, fifth root. So, multiply top and bottom by fifth root of 16. So I can have a total of 5 2's on the bottom. That cancels out. I have y equal to just 2 on the bottom. Any questions so far? And the top is distributed 16. So it's fifth root of 16x minus 3. Okay. Now, graphing that.
Isn't 16 times minus 48?
I said 48. Great, it's recorded. 48. Now, it would be impossible to graph that by hand. And that's why when we graph this, we first graph the original function, because we just spent a whole chapter on polynomial function. And you should be able to graph that with 1, 2, 3, and fifth root means something, fifth power means something like that. That make sense?
I thought it had 5.
When it's odd, it has an S shape. It might have another loop somewhere, but again, I don't really care. The only thing I care about would be the intercept, but I'm not even going to worry about that. For the sake of practicing inverse graph, all you really need is to graph inverse of f as 3 here, here, so I have to do this and that. You see that? Flip by 45 degrees. And there I have just estimated this graph by hand, by using a 45 degree line. Okay? How are we doing?
I don't look at how you estimate the graph.
Do you understand how I estimate the blue line, which is the original function?
You just did,
X to the fifth, the parent function, looks just like x third. That's the parent function. Just like if you remember, x squared looks like that, and x4 is just kind of a little bit chubbier. x6. So x cubed, x fifth just look a little bit wider. x7. That's a parent function. When you add things, they start to wiggle more. So I've estimated that, and the plus 3 is a horizontal shift, the 2 is a vertical stretch. So basically it looks something like this.
So it doesn't have to be that.
It doesn't have to be exact. Yeah. Most likely on the test it would be a graph that you can graph easily, but it's the flip that you get tested on. Okay, one more thing. I know it's quite a bit. At least we're splitting into 2 sections. This is the price of a ticket based on number of years since 1995. It doesn't really matter what the word problem says. Since it's in this section, you know you're looking for the inverse. The tricky thing about the inverse here is that basically you won't switch the variable. Okay? When for example, if my example with the income to let's say 2 times height, right? Height is the input, income is the output. When I look for the inverse function, I don't switch the variable. That doesn't make sense. Height doesn't become income all of a sudden. You simply solve for h. And now you have h is equal to income over 2. Does that make sense? You don't switch the variable when the variable actually stands for something. You simply solve for the other variable. That make sense? You only switch x and y because by definition x stands for so-called input, y stands for output. So when you're switching input and output, you switch x and y. But if right now my input used to be height, output used to be income, and I say I want to switch it now, I don't switch h and I simply solve for h and leave it as h. Okay? Give me 1 second here. I'll do this quickly, and I'll answer more questions tomorrow. So when it says to do the inverse of this function, the goal is to solve for t. That's the first part. The second part, the tricky part is, when you have a decimal power, you would divide it by the same decimal on both sides to cancel out the power. Okay, instead of divided by a 2, make it 1/2 power on the other side, you would divide it by 0.192, make the other side 1/0.192 power, and the calculator will give you 5.2. Okay, if you don't catch that at the very end, that's fine. And that would be your homework. Okay? I'll put that on PowerSchool.
Which ones have no graph?
Just these parts. This part has no graph. Which means that you can skip the graph.